Now the next thing I want to show you is how we can read files and load data into Python. So there are two files here in my folder that I haven't showed you yet. One of them is testdestinations.txt. These are just IP addresses separated on individual lines. I would like to load that into my script and try to see how the router handles each of these destinations according to the routing table. The other file is a JSON file with a lot of entries in it. So there are 100 routes down here, and each of them have a network, a prefix length, and a next hop. So all of that I would like to load into the router. So you see, JSON to some extent looks similar to how we define lists and dictionaries in Python. It's not completely identical, but with the data types that we will work with here, it actually is exactly the same. So that makes it very easy for us to load the data into Python. So I'll create another file out here called testrouter.py. And in that file, I would like to create an instance of a router. So I will have to import the router class from this IP_router module, which is my Python file. So that's the first thing I will do in my test script here. It is to import my IP router module. Because after I've done that, I can create a new border router, for instance. And I can reference the class by using the module name, so the file name, IP_router.router, and then I can give it a host name. Border router 1. So let's just run that test router script. And if I scroll up, then I see that it's still core 01 router that is booting. That's the one I had implemented inside of my IP router Python file. And that's because whenever I'm importing a file, then the entire script is run to completion. So all of the instructions that I gave down here will be automatically loaded. I don't want that. So one way to avoid that is to use the special variable named __name__. So let me just print that out right here. I'll print it out from my test router, test script name. I'll do the same thing inside of my class file here. So print class file name __name__. So I should see both printouts if I scroll to the top. So the test script name was __main, and the class file name was IP_router. So whenever I import another file, then it's recognized by its file name, except for the file extension. But the actual script file that I invoked up here have a special name called __main. So there's a trick here that we can use to ensure that my main script down here is only run in the case where I actually invoked this Python file from the command line directly. And that's with an if statement, where we do if __name__ is the same as main, then only in that case will we be running this main routine. Okay? So the result should be that whenever I'm importing the file instead of running it, none of this will take place. This will evaluate to false because the variable will actually be populated with this content. So I'll save that and run my test script again. So now we see that border router 1 is booting. That's great. Let's populate some routes into it. So I have these routes described in a JSON file right next to my Python file. So let's load that. And the way that we open a file is with the open function. So in here, I can just supply a file name, test routing table.json. And a common way of opening a file would be to either just assign it to a variable. So if is a very common way of identifying an open file. So now that I have my file opened, I need to read it and process it. And since this is a JSON file, then I can do both of those actions with the JSON module. So this means that my border router's routing information base can be reassigned and overridden by everything that's in this file simply by invoking the JSON.load function and passing in the open file. So the F file right here. After that, I would have to calculate the fib. Let's see what happens. All right, we see a lot of entries being added into the forwarding information base. But my file is still open. So let me just print out F right here. And I can see at the bottom of my output that I now have an IO wrapper which has an open file. So every time I open a new file, I need to remember to close it again. So a better way of doing this is using what is called a context manager. And it is identified with the keyword with. So with this open socket as F, then I create a new code block. And inside of it, I'm doing the exact same actions right here. But Python will remember to close that file for me. So I think we should do a similar thing with my destinations. So I have this list of IP addresses that I want to pass through my router. These are just separated by new lines. So I could simply split that file. So I'll open up that file instead. And then I'll assign the entire contents of that file by just reading it. So let's just verify that by printing out the contents of destination. So here I have the data from my .txt file. But this is a multi-line string. So what I want to do now is actually to process the incoming packets with one IP address at a time. So it would be better if I split this multi-line string into individual strings, one for each IP address here, and then treat that as a list of IP addresses instead. And that's actually quite simple. When you have a multi-line string, you can invoke a method on that that's called split, and it takes a single parameter, which is the separator of that file. So my IP addresses here are separated by a new line character, and as you may have seen in other systems, then \n is usually used to indicate a new line, and that goes for Python as well. But this is simply just because we cannot specify a line break like this. Maybe I could actually do like this if I wanted to and print out the destinations. I'll then see a list of individual strings. This doesn't really result in very readable code, so I'll just use that shortcut for the new line character \n. So the result is exactly the same. So now that I have my destinations, I will loop around them. So this is just a simple list. And for each of these destinations, I want to perform the forwarding action. So let's see what happens. All right, so there's a lot going on here. So we see packets that are dropped, packets that are forwarded to different next hops here, depending on what the destination actually is. So all of this is working just as expected. So that's pretty cool. So we are now actually reading files and loading JSON. And then the final thing I want to show you is how to work with timestamps, because it could be interesting to do a benchmark on our router here and see how many packets per second it can actually process. So there's another module in Python for that called datetime. And in some cases, when you import, then you may be interested in importing only specific classes and not the entire module. Usually that has to do with the readability of your code, and it's very common in the cases where a module has just a single class that you actually only import that class, because in some cases you may end up typing unnecessary code. So for something like datetime, it's very common just to import exactly that class. So datetime is used to hold a time value and to do calculations with timestamps. So we could record a timestamp right here. So let's go with T1 for timestamp 1, and we'll assign that to datetime now. Then when we're done with all of the forwarding, I'll record another timestamp called T2. So now we have two different timestamps before and after the processing of the packets. We can then do calculations on that. We can calculate the duration, so the difference between these two timestamps. We can subtract the earliest timestamp from the later one, and that'll just give us a time delta between them. Let's just print out that duration for now and see what is returned to us. Okay, so we get a timestamp here, which is representing hours, minutes, seconds, and then milliseconds right here. So it actually took us 0.226 milliseconds to process these packets. That's pretty good. So let's figure out how many packets per second that is. So we need a few more values to do that. One of those numbers is how many packets did we actually forward? Well, we could count it in the test destinations in here. We have 6 packets, but it may be that we are receiving a lot of packets here, 48 packets, for instance. So I need to count this dynamically depending on what's in my text file right here. So that would be the length of the list that is generated based on that file. So that's what I'm doing right here. I'm generating a list of individual IP addresses. So the length of that list is the number of packets. That also means that we can calculate the average duration per packet by taking the durations total seconds. So that is returning a number. And then we can divide that by the number of packets. So to then figure out how many of those packets we could process per second, it would be packets per second equals to 1 second divided by the duration per packet. You see? So then we can finally print out those packets per second. So let's just use the border router hostname, packets per second. Like that. 15,000 packets can be forwarded per second from that router. Maybe we don't care about these fractions. We can simply just convert that to an integer to round it and make it a little bit more presentable. So we see there's some variation here with every time I run the script, because this is all implemented in software and there are so many things that can influence exactly the performance. So Python may not be the best performing language to do actual network forwarding, but that's not what this is about. The focus here was simply to learn about all of the functionalities of Python that you may encounter when you do network automation. None of the things that we do here is actually automating any networks at all. We'll save that for a different lesson. So I think that you should go ahead and do some different measuring. Maybe you could go ahead and measure some timestamps around other parts of the script file, something like loading the JSON table into the router, or maybe even calculating the fib on its own. Those numbers would be interesting to explore. You could also go ahead and populate this JSON file with some networks and prefixes that is relevant to you. And then you can actually follow along with the forwarding decisions here, where candidate routes are found and a best candidate is determined, and then see how that actually operates if you were to implement a router like this in your actual network. So I hope you enjoyed our little sandbox here where we developed emulated network devices on layer 1, 2, and 3 of the OSI model. You have now seen a lot of concepts and syntax of Python that will be very beneficial when you start to learn about network automation. So you can go ahead and apply this in the real world, maybe not for creating your own network devices, but you can take this to the next level and have a look at real network automation.